So in this video, I'm going to be talking about the electron transport chain. So mitochondria has this like wavy shape, right? And this like space in between is called the mitochondrial matrix. It is filled with fluid, and also just know that this part, this like space outside of the matrix, is called the intermembrane space. Cool. Um, so in the membrane, like this membrane right here. There it is lined with ATP synthase. All right. Let's say this is the intermembrane space. This is the matrix. So the FADH2 and NADH produced in glycolysis and Krebs cycle, also known as the citric acid cycle. I sometimes use one over the other. No reason, no preference. But the one they produce these two, and these guys drop electrons. So on average, FADH2 drops 2, NADH, though NADH produced in Krebs cycle drops 3, but if produced in glycolysis, it drops 2. The main difference is the electrons, simply the electrons use up energy trying to get into the mitochondria because in glycolysis and fermentation happen in the cytoplasm. So you have to get them into the mitochondria. While the Krebs cycle happens inside the mitochondria itself, so it doesn't have to spend that energy. So that's a good rule to remember, all right? Just remember that. So then when it drops off the electrons, it becomes NAD plus and FAD respectively. It is an active transport to go into the matrix. And it does lose a little bit of energy, but it doesn't lose enough to go through ATP synthase and still produce ATP. So ATP synthase is kind of like a windmill, all right? And and the wind that powers the windmill is like the hydrogen ions. All right, we've got hydrogen ions. This forms a gradient, by the way. Just remember that word. So ATP synthase then harvests that and produces electricity, or in this case, ATP, which is the electricity for your body.